Okay, we have been doing little 2-step and 3 steps proofs, and now we've got this big, huge one. So we have to think about how to put all this together. So a couple things. First of all, when there's more than one given, we usually put those in 2 separate lines. So we're going to put this one in one line and this one in another line. Good thing for us, that's an easy point, right? That's given and that's given. Of course, we want to put our x equals 4 down in this last line, and I've already filled that in. We don't know what that reason is yet, so we're just going to hold off on that, but we're going to build up to it and find out what it is. So another thing is we're going to look at what we have and look at the diagram. AB is congruent to BC. So AB is congruent to BC. And BC is congruent to CD. Okay. Then we want to prove that x equals 4. All right, we have AB is congruent to BC, which is given. BC is congruent to CD, that's given. I don't know if you can tell by the way they're laid out here or maybe by the way that they're laid out here. This is a certain property. Look how they both have a BC there. When they both have that BC there, we can call this the transitive property. So I'm going to say that AB is congruent to CD because the transitive property. I basically just like cut out that middle step and just came straight to it. That's the transitive property. Okay, we're trying to get to x equals 4. So if these are congruent to each other, what now? Well, I somehow need to incorporate my x's here pretty soon. Well, maybe instead of saying congruent, because we're about to get into equations, we don't want congruence with equations, we want equal to with equations. So let's make this an equal sign. And if we do that, we can do that. We can just change this into equals because that's the definition of congruence. Okay, now that we have them equal to each other, now I think we can start getting into our x's. And so I'm just going to substitute in. Where I did have AB, I'm going to call it 3x minus 1. And where I did have CD, I'm going to call that 2x plus 3 because I'm able to look at my diagram and see what I have. So you need to incorporate your diagram as you're working through this. Okay, so that's substitution. I want to get down to x equals 4. I'm just solving. What would I do to solve this first? Well, one thing you could do is you could subtract 2x. I'm going to use a different color so we can see it. I could subtract 2x and subtract 2x. I can do that. I don't have to show that step, but I can do that. And what I've done is I've subtracted just now. So I'm going to write down here subtraction property. And when I subtract 3x minus 2x, it gives me 1x. I bring down my minus 1. I bring down my equals. These go away, and I have a 3. All right, I'm trying to get to x equals 4. What do I need to do now? I need to add 1 to both sides. So if I add 1 to both sides, that 1 goes away. I have 3 plus 1, that is 4. And what did I do? I added, so I call that addition property. Okay, so this is a much longer one, right? But if we just go if then, if then, if then, if then, if then we can finally get to where we need to go to. I think of this as kind of an outline. Like we have our starting point and we have our ending point, and we have to kind of fill in how are we going to get there, right? It's kind of like a puzzle. What pieces can we fill in to get us down there to the bottom? Okay, one more, and again, it's a pretty long one, but we can do it. We're just going to go step by step and try to go if then, if then, if then what. All right, so we're going to start with our given. That's an easy point. Okay, right angles. We need to find something that talks about right angles. And on the previous page, if you flip back a page, it says if you have 2 right angles, they must be congruent. So if these 2 angles are right angles, they must be congruent. In other words, angle ABC is congruent to angle BCD. Why? Because, and we're just going to leave as our answer, we're just going to say all right angles are congruent. That's a reason. All right angles are congruent. But again, we're going from congruence down to x equals. So I don't want a congruent sign here. I want an equal sign here. So I'm going to say the measure of angle ABC is equal to the measure of angle BCD. Why? That's just the definition of congruence. We just have to look for the key words and also keep in mind where we're trying to get to and bring together those key words like congruence with what we're trying to get to. Okay, if we know that all right angles are congruent, so we have these two measures equal to each other, if we look up at our diagram, ABC is 2x plus 40, and the other angle, BCD, is 4x plus minus 10. So I'm just going to call that substitution because I just looked at my diagram and I substituted in for my information in for those parts. Okay, I need to get down to x equals 25. I'm basically just solving now. If you were going to solve this, how would you solve it? Well, one thing we could do, we could subtract that 40 from both sides. And so that gives us 2x is equal to 4x minus 50. So what did we do? We subtracted. So again, don't abbreviate too much because substitution and subtraction are different, totally different things, but they could look alike if you called them sub. Okay, I'm solving for x. What do I need to do now? I think I need to subtract my 4x. Move it to the other side. And what do we call that? Once again, we call that subtraction property. And what that leaves us with over here is a negative 2x equal to negative 50. I will also say these little things that I kind of scrunched in here, you actually don't need to put those and probably even shouldn't put those. I'm just kind of showing you where I'm getting it from, but you really don't need them. And the next step, if I'm solving, I'm going to divide by negative 2, and that's going to be the division property. And that gets me down to x equals 25. And I actually have an extra line here. I should move my x equals 25 up here. I solved it in less lines than I needed. And the reason is because I subtracted 40. If you had subtracted the other way, and you might have needed another step, but we did this here. Okay, once again, the idea is if then, if then, if then, if then. Another idea is we're looking at the key words and we're looking at our definitions and seeing what could that definition mean if we have that key word. And we're trying to figure out if we start here, how do we get to down here? So you're trying to fill in all the steps in the way. We will be working a lot with proofs the next couple of days.